announcement before we get started. There's going to be lightning talks from 4:15, so if you're interested you can sign up at reception. They have a list and they'll be going on in here afterwards. So next up on this track we have Glenn, who's going to be talking about how we can make the web a safer place and everything, and how sharing knowledge can make everything better.
Yes, thank you. Thank you very much. So welcome everybody. I'm really glad to see that there are so many people interested in this talk. Yeah, as you notice, I'm in the rookie section, so I don't have that many experience presenting, so I will do my best to share the knowledge. So, the Security Knowledge Framework is an OWASP project that's being created by me and my brother Ricardo. Too bad he couldn't be here today, but will do. So yeah, we started this project almost a year ago because we felt that we really needed to do something about the whole missing information, the not sharing, and we wanted to do something about it. I have also an agenda to have an overview of what you will see and go through. So let's just start why the Security Knowledge Framework. So as I said before, there was a lot of missing security as a design. So people and developers aren't really aware of all the possible attack vectors that are capable in an application. And well, they go through the development phase, then they get a pen test, and in there you have a lot of findings. They map those back again, fixing them into the application, and security is basically then a sort of a layer on top of a pile of do or something. So it is just an after thingy, right? And well, I and we think it should be done by design, correctly, with the right awareness to create certain functionality. Also what I'm really missing, what we really see missing, is the defensible coding approach. So every example you will see on the internet, if you really look hard, you can get some good examples, but again, the defensive coding principle it's not in there. Also the security guidance. So you can have a security requirement inside your company, but then it's basically per person on how to how they see it and how they know, and what type of information they have to do the correct follow the correct path on how to properly create the functionality you want. So also guidance is guidance is also missing. And of course, like I mentioned before, the security requirements. A lot of development parties don't have security requirements. So after they developed all the code, there is a pressure on releasing and getting to the next project. They found out that a lot of things need to be fixed. A lot of them are structural issues, like the call-side request forgery tokens or properly escaping user input. Of course, a big one is security is hard. You find a lot of ways on not how to do it, and even the books and the examples you will see to teach you how to program will not mention anything about security. Security is really hard. We think the security information should be available for everybody. I mean, this is knowledge that is needs to be shared, right? I mean, you all went to the hack about the database and people committing suicide and about the information that got out there. And we need to team up, right? We need to do this together, and we all can win when we're doing this and making our applications defensible and really secure. So that's basically why we started the whole project, like what I said, most like a year ago already. And now it's really in a mature phase where also OWASP has adopted it and speaking about it. So an interesting thing I think is what you will get and learn. So yeah, basically a guide to secure programming. So like I said before, do security by design and not implementing security afterwards. And big thing is also the security awareness. It will inform you about the threats even before you write a single line of code. And that is a specific core functionality inside the security knowledge framework that I will show you later on. So yeah, it will create the awareness among the developers to know what is possible when dealing with certain type of functionality. And of course, I think this one is also a very important one, a central place for security reference. Because I also found out that when I was looking for good code examples or good explanation of an attack or mitigation, I had to crawl the whole internet, do an assessment, audit the code, found out, oh, this is bad code, so ditch that again, go looking further. It was really a time-consuming thing. And the other thing was, who makes this user on the forum somewhere an authority that I should believe in, that he's saying, the correct thing? It's not really open source or easy to adjust. It's just a forum post somewhere on the internet, right? So that's why we also wanted to create a central place for all your security reference in application development. So yeah, you don't have to Google find in here there is the content you are looking for in the code examples. Everything is also available on GitHub, so you have the auditability, it is open, everybody can see, edit, modify and contribute. So that's why I think this is really also a good thing. What you also will see later on, I have 2 demos today, so can you guys be with me? I hope they will be awesome. And yeah, again, I will point this stuff also out to it, and the software development lifecycle of this project itself. So Security Knowledge Framework is a web application with all content, code examples, threat analysis, checklist for verification, all that jazz, but we also used the same principles we tell in the project itself. So we have fully automated it like a DevOps way with continuous integration tooling to keep the quality, and but I will go into that later. So first I want to talk about the stages of development. So in the Security Knowledge Framework we have 2 stages of development. We call them the pre-development phase and the post-development phase. The pre-development phase, that is basically when you're in the designing phase. So you have a new project or a new sprint, and you have from the owner, the product owner, hey, I want this type of functionality, and you will define it in the pre-development phase. So in here you can basically select the different type of functionality or functionality steps you want to implement or create in the new project or sprint. And the Security Knowledge Framework will correlate those type of functionality to a knowledge base item. And the knowledge base item is basically saying, hey, this is the description of this item, and with the description we try to explain what the attacker can do when a developer is not properly mitigating this issue or attack vector. So it is basically sort of a threat analysis system where, like I said before you even write a single line of code, the developer is getting aware of all the attack vectors. So he can take that into consideration and into his project, and and already take it with him and do it as by design, like we want to. Then when we have that phase, then we have also the post-development phase, and basically this is when you already created code, so it's sort of a verification step, the last final check before the developer hands over the code, and it goes to the manual pen testing, etc. By the checklist, we are using the OWASP SKF, that is the OWASP Application Security Verification Standard. It's a project that's already dating from 2011, and it's used by military, governments, financial, all kind of interesting organizations. And why is that? Because it's the name already says itself. It's really advanced stuff. The security controls in the checklist are like around 160, 170 items on a different category for the whole stack of your web application. And basically they have different levels in it. That's what I want to talk about now. Because, well, you have the level 1, that's easy, not too hard stuff, but yeah, you need to start somewhere, right? So the level 1 is to start. The level 2 and 3 is, well, this one is basically what I always use, because where I work we only have critical web applications. So for us, the security requirement in our company would be everything that would be built, new or improved, is going to be used the ASVS level 3 as a security requirement, because that's the really in-depth shield and you know, that making your application defendable, and also very secure, as I will show you later on. So I now talked a little bit about the security knowledge framework, the post, the pre-development phase, the knowledge base items. And now I really want to show the framework itself. So basically what I want to do is show it and tell about the functionality, and afterwards I want to give you the complete overview of how I'm basically using this in all types of companies. So think about my own company, giving guidance and helping the developers there, but also going to our partners and third parties to spend the day there, explaining them the work, the security knowledge framework, and how to apply it in their organization. The security knowledge framework was really intended to be for the developer, so it was also created in the Python Flask micro web service script language, stuff like that, so you can run it on your local machine. Everything you need is on your local machine, but we're also improving it and making it, you can install it as a service inside your company with user roles, management, stuff like that. So I first want to show you the demo environment. So basically this is the security knowledge framework. As you can see, it is just, like I said, a micro web service, web application, and in here we can manage and use the security knowledge framework. Before I go into the pre-development phase, post-development phase, I first want to start with the knowledge base items and the code examples. Because the knowledge base items, that is something we heavily depend on and correlate those in the pre-development phase and in the post-development phase. As you can see, you can search through the knowledge base items. So if you want a specific type of reference, so you want to know file upload injection, what was it about, what type of things I need to think about. So basically what you can do is then search the item in the knowledge base, and in here what I said before is trying to explain the different type of attack vectors an attacker has when you're not dealing with this attack vector, when you don't have something for it on a code level. In the solution we then try to like I said, guide the developer in the right mindset to mitigate and defend against these type of attacks. So for all the ASVS items, we have a knowledge base item in there, and also for all the pre-development technology stacks you can choose, we also have a knowledge base item for it. I will scroll a little bit down. As you can see, there are a lot of items in there. Like I said, that's due to the ASVS that already has 160 security control items in there. But basically all those items you want to apply and implement as a design phase in your application from the beginning. And to do so, we have the pre and post development phase. Also a thing in what you noticed, I didn't really describe the attack vector in the knowledge base items, like how an attacker would inject this or abuse this. We choose to not do that and just to create a generic type of content and text only, because like OWASP has a lot of good examples for that already on their wiki. But this and for the developer, like just creating the awareness, the possibility, hey, be aware, like he doesn't know how to, that is documented on places enough. But really a reference in one framework where all the knowledge is in, that's nowhere. So that's why we focused on that, just bring the awareness to the developer and give him the right mindset to mitigate the attack vectors. But like I said before, the text is really generic. I mean, that's also a problem I have with a lot of paperwork. It's just paperwork. It's really hard to use it. And again, they give you a sense of awareness, but you all know that when it comes to implementing type of functionality or a vision or an idea, you still can have big security issues in there. So that's why we also decided to go to the next level, in a level deeper, right? So what we did is we created for multiple code languages, and I'm currently busy building Python examples. Jim Manico and Martin from OWASP are building Java examples. We now do have PHP and .NET already, and we will continue adding new examples because we think this is also very important. This is really showing the developer on a technical level the same language he speaks on how to properly mitigate and how to handle with it. So again, if I would pick here, for example, the file upload functionality. So in here I have a PHP function, or in this case a clause, where we do the file upload handling. Don't know if you're all familiar with PHP, but in PHP you can do a file upload in 3-4 lines of code, and then you can have the functionality, you can upload your files. But as we all know, that gives, if you do it that way, that gives the attacker the possibility to upload his own code, compromise the whole server, and from there go into your network or whatever he wants to do. And then again, look at this code example, how we try to do all the steps and explain why we're doing type of steps. So, for example, here we do an input validation. And why? You will see this a lot in all the examples. We always do input validation. And why we do that? Because we want to verify and also trigger and log that in this case the user had an invalid file name and it's a modius, a medium type of attack vector. So if it does go wrong, you can easily see from the log, oh, this is interesting critical functionality, that's not cool. Again, well, we do that in a header location redirect, and then, well, if it does pass this, we go through. Again, we go validating, make sure the last extension is preventing, so, the good old double extension trick. So it checks for the, hey, is there a .gpg in there? Oh yeah, it is, it's good. But yeah, when you do a .php, it will also just go through, right? So again, we have different type of mitigations for this. So in here you see a piece of code that is doing the analysis and checking of the extension. And again, if it's not correct, it will log and also, well, in this case, set a high as a risk score. In here you see also, when this fails, then we set a counter. In this example, if the counter hits 3, the user session must be terminated. After 3 sessions terminations, the account should be blocked, since the high threat level will lead to immediate session termination. So basically we're using the intel and the threat, so low, medium, high, and with that we can set higher or lower counters. In the security knowledge framework, in this framework, if you try to inject here cross-site scripting, SQL injection, after 5 counters you will kicked out and the account will be blocked. Of course, locking out of accounts, that can be also led to denial of service attack. So we choose to implement it in this way, because then it's really visible. Also, people trying to hack the demo will be kicked out. So again, what we really try to do in the code examples is really step for step going through and why we're doing this. And well, for example, this is also a very funny one in PHP. So if you can remember this one, the header, if you won't do this die, then, like we mentioned here, the rest of the PHP code is still being executed. So if you would print under this line's variables or whatever, the attacker can still see the content because there is no die after a header redirect, for example. So again, we really try to, for every step, taking the developer, give him the right guidance to, how to tackle this attack vector. And you know, the code examples, the idea is not to copy paste. We checked it, we injected it, the syntax is all correct, but it's only there for training, right? To get the right mindset. And yeah, hopefully you will then do yourself, implement and do security as design. Well, we can also pick the .NET version, file upload, and in here you see how we would do it in the .NET version. Again, the same principles. Before you do an action, you log. And before you log, you validate. So here's first validating, checking if it's passing or not. If not passing, you're reporting and logging that. After that one, you log it. Hey, I'm going to do this action. And after that, then you do the action. And it sounds really like, duh, but I saw a lot of code and did a lot of code analyzing and auditing. And I saw a lot of times happening that they first do the action and then they log, hey, this action has been done or triggered or whatever. But there is already a major flaw in it. And it is when an attacker has a successful attack vector and it exploits that type of functionality and you log the action afterwards, yeah, then there is a chance that you won't see any evidence of the attack if it was successful. So that's why you want to validate, that's why you want to log, and that's why, yeah, the whole mindset, the whole approach on how to do this. So yeah, this is basically the code examples and the knowledge base. The code examples are for reference, to go in depth, to check, okay, what are the steps I need to take. And again, the knowledge base items is being used in the pre- and post-development phase. So that is what I want to show you now. Is basically, so how would I use this in well, third-party, customer, other partners, companies. How I would use it is first we need to define a security requirements, because without that, you know, we cannot blame the developer anything. If we don't give him requirements, that's makes sense, right? So first we need to be consent about what type of security requirements should we apply. So again, I am a real proactive user of the ASVS, the level 3, because that's critical for critical applications. Really go in depth, and well, basically, you make that arrangement. You say, okay, we're going to use and apply the level 3, and when we all agreed upon that, then we can continue using the security knowledge framework. So in here, I want to create a project. And it's just a fictional project, so it doesn't really matter the name. Then I can select the project name. And like I said before, here we have the pre-development phase, the add processing functions, and this is the post-development phase when we already have code. So first I'm going to through this one, the add pre-development phase. So in here you can see different type of functions you can use, and are very common in web applications, that there are sort of components, technology stacks that are very much used in applications. So what you can do is you can add new functions. So you're in the designing phase, you want to create new functionality, and well, So in this sprint, we're gonna do adding user display plus login, something like that. That's well, a use case that's very common. So what we now can do is add function. And the add function spawns a drop-down menu where we can select the different technologies we're going to use for creating this type of function. So because we are going to display users and do login, we select HTML because we're going to use HTML to display the user's name in there. We're going to do forms and we're going to do, well, sessions. So now you can say add values. Okay. Demo gods were not with me today. Let's see. Oh, I see. So I said about validating, right? And we are very strict in validating. So I put a plus in there and the application said, no, I don't. So now it already flagged also the counter one up, right? Like I mentioned before, setting counters, keeping track. If it has a certain threshold, take an action. We decided after, like I said, 6 times the whole application drops and is locked. Of course, like Dan said, if you have a nuclear power plant, that would be an issue. Yeah, so let me redo it. So adding the HTML and saying forms and sessions, and now it will work. So you get a function summary, as you can see, function technology, okay, all done. This is, well, what we decided upon, this is the functionality we want to add. And now the security framework has correlated those type of technology stacks through a knowledge base item. So it hooks them up and correlates, sort of a threat analysis and making the developer already aware of all the dangers and that are lurking around the corner. As you can see, for example, when you are dealing with sessions, it's not just only one thing you can do. There is basically a whole design pattern you need to implement. And again, if you don't do one, the whole session management layer is broken, can be defeated by attackers. So if you forget the HTTP-only flag or the secure flag, still is an attacker able to sniff it, steal it, set it himself. So again, in this case, it is a pattern that is making the developer aware of all the work and things that he needs to think of. Well, again, for the submitting of forms, it is it is best practice to say, okay, hey, the first thing you need to have is single user input validation controls and audit logs in a central place. Then, of course, the cross-site request forgery tokens. That is a thing, if you don't add it in the beginning, then it's a structural issue and you would take a lot of time to implement it later on. Also, there is the problem that it's really easy to forget one form. So again, it should be part of the design, right? Principle of least privilege, and of course the get/post request. Think about which one you will use. Because if you're using a get and you're submitting a password field or whatever, you're losing all that information in the browser history, in the referrer, and all the third-party application that you hook in, like Google and all the JavaScript stuff. They all see that information that's in the get. So even the difference between post and get is important. And again, we try really to guide the developer in the right mindset to make the application really defensible. And again, for HTML, a lot of problems can occur with that. Content spoofing, image tag injection, base jumping, element override, hidden text areas. There are so many cool stuff an attacker can do. So, like I said before, this is the pre-development phase. So now this is something a developer can click together and have already, the awareness like, hey, think about this, think about that. And of course, with the ASVS as a security requirement, you have a very good starting point. But of course, like I said before, implementing, that can also be tricky. There are 170 security controls in there. So if you would ask me on a Monday morning, Glenn, go fix those 170 security controls in your application, I will probably forget like 10 or 20 or maybe 30 because I drove too much, you know, the day before. So that's why we also want to do a verification. This is not enough. This is only the awareness training. The idea is, when you use it more often, that you basically can skip the whole pre-development phase, you know everything, and in the post-development phase you have the verification step where you go through. I will show you right now. So, when we have this, the developers have the document. I didn't show you that, but all the information and the correlation of the items can also be downloaded as a docx document that you can send to other colleagues or management or whatever, to also have for them clear what items were applicable or not. So, like I said, that is the pre-development phase. You didn't write a line of code yet. Now we're in the post-development phase. You write your code, it went through your build street, it passed everything. So basically, you're almost ready to deliver it to, well, the next person, to deliver your project. But before we do, we want to do a verification. A verification if we have all the security controls in place and we applied all the ASVS levels. As you can see here, there is a OWASP top 10 list in here, but I call it technical debt. And I also want to make clear something. OWASP top 10 is not a security requirement. People who call it a security requirement should be taught and teach like, no, ASVS, that's a security requirement. The top 10 is not. So I want to make the difference really clear, because I see a lot of, in the security industry, they calling this a security standard, and that isn't. The ASVS, that's the security standard. Like I said before, we have different levels. What I always use is, of course, the level 3, the advanced. And what we also did is created a custom checklist, and basically this is just a skeleton. So you don't have to really dive into the technical stuff of the framework and how, you know, the security knowledge framework, but just adding markdown files to the GitHub or in the right folder. It will automatically populate this, and then you can point this one to knowledge base items. But also I will show you that later in the software development lifecycle of the security knowledge framework. So we're now in the post development. So I created the code, and now I can start this section. So what you will see is a lot of different categories. Well, this one, it starts with the authentication verification requirement, where we have different security controls to mitigate issues and attack vectors on this topic. Also, you can see the colors. That's depending on which level this item is coming from the OWASP ASVS. So the blue one, that is really the level 3 die-hard stuff for really important applications. Again, what we found out, this is a really helpful list. But I even had issues decrypting it. Like, what do they mean, or what do they want to achieve with this item? And again, because we all correlated those items to a knowledge base, we can also fetch the description of the item and show you when you hover over it. So you get a little bit more context about the checklist item that you need to verify that you have implemented it. So how I normally, or how I am using this is basically together, sit with the developer. I'm using my security mindset, paranoid, human taint analysis, right? Go sit next to him, and I'm asking him basically, hey, verify all page and resource requiring authentication. Now, and he will show me in the code, because he has written the code, he has the context of where it is and how it's hooked, and he will show me how he implemented it. Then I will challenge him, saying, hey, you thought about this, I see this, what's about that? Challenging, if it's a good answer, good technical answer, it's all good. And then we can just say, yes, this one we did, next one. And we go through the whole list. I can already hear you guys think like, yeah, but it's a lot. I don't want to go to the session management, access control, malicious input, crypto, error handling, logging, data protection, communication, HTTP security, malicious, and business logic, and last and not least, file resources. I can tell you, it takes me together, like extreme programming in good old days, it will take me like a day to do this together with a developer and assess and check all the implementations they did. And then I'm talking about a big web application project where months of work has been put into. So really, by using each other, and like I said, I'm using my colleague, the developer, because he has the context, he has the how it's been created, and I challenge him by using this checklist and looking with him and challenging him. So when you submitted the whole list, you can again save the checklist, and it will now correlate all those checklist items, like I said before, to a knowledge base item that is applicable. For this one we selected no. So this is a really big list. But basically this is the output that the application will give to the developer. So verify all authentication will fail securely, and to ensure attacks cannot log in, all authentication controls must fail securely. So this is a knowledge base item that's being correlated now to that checklist item. Well, like I said, this is a really big one, and I wanted to show you also that you can see it's working. So I found out that Safari, when you download a docx, it puts .html at the end of it. I don't know why it is. It will say error. Unauthorized, of course. I shouldn't trigger it too much. Like I said before, then I need to reboot the machine or wait 10 minutes. Yeah, this one does work. Safari is not good line. So like I said, it will generate a docx that you can send around with the project, the date, and again all the table of contents of all the items that has been correlated to that security control item. So basically this is, like I said in the OWASP project, the first step in your software development lifecycle. I mean, this is like training, getting the information to the developer and making them aware of all the attack vectors. Now I want to go and tell a little bit about the software development lifecycle we use in the Security Knowledge Framework. The Security Knowledge Framework uses a couple of continuous integration services. For example, Travis. So Jenkins, Travis, basically all the same. Well, it does test and deploy with confidence, easily sync GitHub projects. It has a hook, so if you change something on GitHub, it will notice, pull in the new source and start building your project. I use coveralls for displaying my unit testing information in graphs and metrics. Very useful. And I use Scrutinizer for a code quality check. So it will check for duplication code, bad code, dead-end code, all that stuff. Because it's, like I said before, it's all continuous integration. So if a user would modify something on the GitHub, the whole chain will be activated and we'll go through the whole process. Of course, there's also some manual work, right? And basically, the code review. So, code review, all the code will be reviewed at first. Later on, you will only pick out the specific high-risk things, like you want to add new type of small functionality to the login page, or password forget, or change something there, or user management. Those are really critical points in your application, and you definitely want to code review that and have the 4I principle. Of course, you have heard it before, the SAST, so the Static Application Security Testing. It analyzes it from the inside out. And the DAST, the Dynamic Application, from a running point of view, it will test. And basically what I want to do now is show the demo of the Security Knowledge Framework Continuous Integration. So what will happen? So let's see. First, I want to show you the Travis, the code quality, and the coveralls. So in here we have the Travis CI, and that is hooked to the GitHub. So if I now make a change to GitHub, Travis will notice, pull in the new source from GitHub, and start building the project with the new changes. In here we can have an example of the output. So as you can see, it clones my GitHub project, it installs the dependencies, it installs Flask, it installs coverage, it runs the setup and test it. That went all okay. Then we use the PyTest module and to gather and generate the metrics of the unit testing. And when the unit testing has been passed, then we call the coveralls and update the metrics to coveralls. Coveralls is also a service, and it will display your metrics in a very nice way. Also, what I really like is the coverage. So when somebody is creating or destroying your functionality and it ain't working, the coverage will drop because one unit test or multiple will fail. So you have an instant feedback that, hey, I made a boo-boo. So very nice indicator of something is not good, right? And when the coveralls has successfully been run, then we have the last continuous integration service, and that's the Scrutinizer. And what Scrutinizer will do, it will see what type of new functionality is added, and well, in this case, it will also tell you when it got worse. So duplication code, dead-end code, like I said before. Again, with every commit to the GitHub project, you can immediately see if the grade is dropping, somebody's messing up, somebody is slacking, right? They don't do a proper job. Otherwise, the code would improve or be stable, right? So now I would do a demo about just showing you the whole chain and how it's being run. So first I'm gonna do a normal one. It would just trigger it, build it, everything will okay because I just added a space to the readme, so that can't go wrong, you would think. So if we now go back, then we can go to the Travis. And Travis, normally, it will pick it up and will pull in the source and start building. That's also nice to mention. Travis is fully free to use if you have an open source project. By the way, all the continuous integration, the security knowledge framework, everything I talked about today is open source, is usable by open source projects. So if you want to use it in your company like Travis, you have to pay for it, but if you have your own open source project, you can get it for free, set it up, and yeah, have all the benefits of it. As you can see here, Travis noticed the change on the GitHub. Started a new build job, as you can see here. It's already running for 40 seconds. And basically, it's now installing the whole security knowledge framework, installing dependencies, all the modules that's needed, crypto, XML. Well, it takes around 2.5 minutes, 2 minutes, and then the whole build's complete, and it will be build passing again. Now it's yellow because it's busy. So yeah, that is basically a happy flow. As you can see, when it's finished, it's build passing, everything is okay. But now I want to do let's say 48. I need to remember that. So this will let the build fail, because we now have a syntax error. This one is almost done. And you can also download, follow the log. It's almost done now. And yeah, all this jazz you see, it's normal manual work, right? You have to, I made a new release. Okay, remove the old one, get the new source, blah 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 blah. And then you find out, oh yeah, but I already installed a module, I modified something, and with a new fresh install, I don't have the module, and the build fails. The stupid things like that, right? And now you can, automate it all the way, let it continuously integrate in your build cycle. We also modified the other one, so I hope it will now see the change we made a few seconds ago. And as you will notice, it will then say error, build failing, and also on the GitHub project page, it will display it like build failed, red. Immediately you can see there's something wrong. The same thing for the coverage, and the same thing for the scrutinizer. And I hope Travis is picking it up. Not yet. Yeah, I did change it, so that's good. Here it is. It's almost done also. So, as you can see here, the unit testing is now failing. It cannot run the unit testing anymore. Error here. If we now would go back to the normal project, you can see, if I refresh it, okay, it's red over here. It should put it back here. Okay, well, the image is a little bit slow, but normally it will be red, failed, and you know immediately that's wrong. Also, a good thing is, when you make a fork of this project, and you develop in your own GitHub account the framework, it will also still trigger all the Travis, the scrutinizer, and the coverage. So even if you fork it, the other contributors, the other developers are getting the same continuous integration support, even though it's not, their GitHub project. It will see it. It will take it with it, and also when you make modifications, you see in your own project, on your own branch, in your own GitHub, the build failing, the build passing, and all the metrics of that code. Well, an example of how you would define a Travis file, and basically this is the setup, the instructions on how to prep the clean image, and make it that you can run and test your project on. As you can see, you can also try and do multiple Python versions to have more coverage for older version or new ones. And I was hoping now, this is now, build failing. So let me switch now back to the PowerPoint. To summarize, first, you choose an ASVS level as a security requirement, and if you don't like ASVS, you can also pick another one, that's no problem. Apply the security knowledge framework in the pre-development phase for awareness. Apply where possible the continuous integration tooling. Don't forget about the manual, as they all say, work, because there's always manual work. The automated tooling are helpful, and it's good stuff, but still you need to manual interpret it, check it, verify it. And do the code reviewing, the manual pen testing, of course. Apply the security knowledge framework post-development. So, as I mentioned before, as a verification. And bang, you just created a part of the web secure by design. And like I said also before, all the services used and mentioned in this talk can be used if you have an open source project, so I encourage everybody to use them. And if you want to know how to implement, there are good tutorials on the pages, and of course you can have a look at the security knowledge framework, how we set it up. Again, getting involved. We really want to share this knowledge, make it even better as it already is. We also, hooking into the ASVS team to also add value there. I know that you guys are a lot of experienced people with also knowledge, and we should share this information because I cannot bear to see it anymore. All those weak, insecure applications. It's also my data that's in there, not only yours. So I see it as a win-win for everybody. So questions? Was a lot of information, so
you mentioned a couple of sources that you're using to build this checklist. Was there any particular set of sources that you used? Like, was it more like industry knowledge, industry best practices, like you mentioned, OWASP SKF, ASVS?
So basically we first like a year ago, before we really had the framework, we used a Dutch checklist, but it wasn't that extensive as the ASVS. No, it was again an open source type of organization that also wanted to add transparency, and they decided to create a checklist on how to properly do it. But it is a mixture of a lot of experience. Like I said, or not, I started out as a web application developer, and again I saw a lot of security issues, and was really intrigued by it and picking that up. I was hacking since I was 13, hacking Unreal Tournament, modifying the engine, building aimbots, stuff like that. So I picked that interest up again, and then I moved after 4 years to a security company, being a penetration tester, code auditor there for more than 4 years. And now I'm working at Schubert Phillips as a security engineer. So like think like the ACS, the checklist itself, that's of course all work of OWASP and all the people that contributed. But all the knowledge base items, all the code examples, well, the idea of the pre-development, post-development, that is something we created. So yeah, and it makes it a little bit, like I said, more context, and even we had issues like, huh? So for a developer, it should really blown his mind, like when he wanted to use, but couldn't. There were still, it was still out of reach, right? Too hard. So.
Framework to demo itself. But am I right in assuming it's something that you download and install on your local internal server itself?
Yes, that's true. So we also have a very extensive README, SKF. Also, like I mentioned before, all services we use are free. If you have an open source project, readme.io, I really love this this service because it gives you the opportunity to style. It's just a little bit better, right? Also a support function where you can chat and have discussions with people. So, and to answer your question, when we go to the installation, we see for basically every platform, Ubuntu, Mac, Windows, how to set it up. I also made an Apache WSGI setup, so you can also pin it to a real web server and do proper TLS hardening. And because I found out Flask, I couldn't do that. So if I spin the application locally, I only get like IS2, IS50, and not the real perfect forward secrecy ciphers and the real good stuff, right? So that's why we decided also to create a how-to for this, and for the later vision, where we also want to use it in big enterprise environments, where they want users and audits and separation of documents and projects. Where this also will be useful. Also building and working on the Docker installation. So if you have Docker, you can just type and then everything is running. We will focus now more as a service because a lot of companies really want to implement this. And like I said before, when we created this project, the initial phase, it was not for companies. It was for developers to help you, guide you, and then again, we see the need. So we're also going to make a service out of it. Any other questions?
The manual step, which is, to my understanding, is the longest step process. Is there any possibility that that could be semi-automated? So you got the code that is running through unit test in your CI, then you got the scriptionizer doing your scriptionizing on it. Could you not do the static code analysis and all of that?
Exactly.
To bring that in
Yeah.
those reports.
But why I said manual, because the output those tooling SOST will generate will need manual work to validate and verify it. And like you saw the great SOST tool that was shown in the one of the first speakers, it's really hard to cover everything with it. So I would say to everybody, use it as, if it's possible and it doesn't generate a lot of manual work, do it. But I would prefer doing security by design, having the knowledge yourself, and from there choosing the right path to mitigate certain attacks. So that's also why we created the whole security knowledge framework. We could have created another tool that will test and hack for you. But again, the developer isn't being taught, so he will make pretty easy, again, the next time he creates the similar type of flaw. What we're really trying to do here is, giving you a fishing rod and telling you how you can fish. And so you can provide for yourself instead of buying your fish and then after 2 days it's stinky. And yeah, you know the story. This is, you know, it's basically the same vision and story the aviation have, right? They are sharing information. And why is that? Because, yeah, our lives depends on it. If you know, one customer agency has the same type of airplane, yeah, why wouldn't they tell the other one, like, hey dude, you can crash down? And you know, you see in that field, this is really common already. And that's why we can go into a plane, safely, you know, fly and land, because they are working together. So I think with this project we should do and have the same attitude, the same mindset, right? Sharing. It's all open, it's all there. Like I said before, it's also the content, the code examples, it's all in markdown format. So even if you don't have really technical skills about Python or whatever, you still can add code examples of knowledge base items or extend the checklist. Thank you very much.